This short video will provide machine operators with a brief overview of emissions regulations, after treatment, the operator interface, as well as 3 simulations that demonstrate the regeneration sequence. Non-road diesel-powered heavy equipment must meet new emissions regulations being phased in beginning in 2011. These regulations are referred to as Tier 4 Interim in the US and Canada, Stage 3B in the European Union, and Step 4 in Japan. Caterpillar developed ASSERT technology to meet current and future emissions regulations. ASSERT improves combustion efficiency and reduces emissions. After treatment, first used with on-highway trucks, was added specifically to help meet these emissions regulations for non-road machines. One of the key emissions being removed using aftertreatment is particulate matter. The 2 primary particulates are soot and ash. Soot is made up of unburned diesel fuel and engine oil. Ash is residue from a variety of engine oil additives that didn't burn. Periodically, the soot must be removed using a process called regeneration. Machines using the CAT C7.1 ASSERT to C18 ASSERT engines have a serviceable canister containing 2 after-treatment devices, a diesel oxidation catalyst, or DOC, and a diesel particulate filter, or DPF. As exhaust streams through the canister, the diesel particulate filter fills with soot deposits and needs periodic regeneration to remove the soot and maintain filtering efficiency. Ash that accumulates in the filter is removed every 5,000 hours using a special service procedure that requires the filter to be removed from the canister. The CAT Clean Emissions Module, or CEM, contains the after-treatment canister and a combination of other components from the list shown depending on the machine model. In many machine applications, the CEM mounts directly over the engine. Active or high-temperature regeneration used on the CAT C7.1 ASSERT to the C18 ASSERT engines requires a supplemental heat source for regeneration. The CAT Regeneration System, or CRS, fits ahead of the DPF canister on the Clean Emissions Module. This device has its own source of combustion air from the turbocharger, diesel fuel from the machine's fuel tank, and spark ignition. During regeneration, exhaust flowing through the CRS is heated, which oxidizes the soot in the diesel particulate filter and converts it into carbon dioxide and water. While operating in automatic regen mode, there is no operator action required to initiate a regeneration cycle. Be sure to check your machine's operation and maintenance manual for the inspection points on the Clean Emissions Module. During your walk-around inspection, the various fittings, connectors, and clamps need to be inspected. There are 3 regeneration settings: automatic, manual, and disable. Automatic mode has 2 programmable options that enable the engine ECM to initiate regeneration. At the low-speed, high-speed setting, low-speed regen occurs when the soot level in the diesel particulate filter is 30% or greater and the machine meets certain conditions near low idle. Should the soot level reach 60 to 70%, high-speed regeneration occurs while the machine works. If preferred, the ECM program can be changed to low speed only to provide regeneration while at idle and disable the high-speed option. The advantage is that low-speed regen uses less fuel than high-speed regen. Manual mode enables the operator to override auto mode and initiate regeneration using the manual regeneration switch in the cab. This can happen as early as a 15% soot level is reached. Disable mode enables the operator to prevent regeneration from occurring while working around combustible materials or airborne dangers such as gases or dust. However, soot continues to accumulate. Tier 4 Interim Stage 3B machine operators must be able to recognize the various regeneration alert indicators and understand the switches that have been added inside the operator's compartment. These include the soot gauge, alert indicators, action lamp, and multi-level warning system. The soot gauge is a bar graph that slowly moves from left to right, from 0 to 100% as the DPF fills with soot. After regeneration, the soot gauge will reset to 0. The manual disable switch is located in the cab and has two different designs based on machine model. One is a spring-loaded rocker switch that controls two different features. Press and hold the top half of the switch for at least 2 seconds to manually initiate a regeneration cycle. Press and hold the bottom half of the switch for at least 2 seconds to disable regeneration. If neither function is activated, the system remains in automatic mode while the switch is in the center neutral position. The alternate switch design separates the two functions into individual buttons that also must be depressed for 2 seconds. The disable feature is important if the machine might be temporarily working around flammable materials, gases, dust, or similar applications. In these situations, automatic mode should be disabled. Machines that constantly work in these conditions will normally have the automatic mode feature disabled in the ECM or machine software. Whenever a machine's key switch is turned off, the system defaults back to automatic mode. If you had regen disabled, you'll need to press the switch again when you restart the machine. The DPF lamp illuminates when the soot level reaches 90% and above. It alerts the operator that regeneration is required. The regeneration disable lamp illuminates any time regeneration has been disabled. Regeneration can be disabled by an operator using the manual disable switch in the cab or by a service technician changing the engine ECM software with CAT-ET. The Regen active lamp illuminates any time regeneration is taking place. The lamp is activated as soon as regeneration begins and goes out as soon as regeneration ends. Keep in mind that when the lamp is illuminated during regeneration, the exhaust temperature is higher than normal. This visual identifies the various components inside the cab of a CAT M-Series motor grader. The operator interface consists of the gauge cluster, the CAT messenger display with the DPF soot gauge appearing on the left and the regen status appearing on the right. The display we see shows that regen is in auto mode. The manual disable regeneration switch is found on the switch panel located on the right-hand cab post. On the front panel below the instrument cluster are the DPF lamp and regen active lamp. The operator interface on CAT hydraulic excavators consists of the liquid crystal display that now includes the various regeneration indicators such as the regen active lamp, regen disable lamp, and DPF lamp. The DPF soot level appears above the gauges at the top center of the display. On the hydraulic excavator, the bar graph style soot gauge is replaced by a numerical percentage from 0 to 100%. The manual disable regeneration rocker switch is located on the right-hand console. The operator interface in the CAT medium wheel loader operator compartment consists of the Generation 3 instrument cluster, shown on the left. Regeneration indicator lamps are located below the gauges. Regen status can be viewed on the LCD screen. The manual regeneration and disable regeneration buttons are found on the panel located on the right-hand post. In this section, we have 3 different regeneration scenarios using simulated automatic, manual, and disabled modes. All 3 are based on a wheel loader cab mock-up. We'll start by tracing the automatic regeneration sequence. Regeneration status is first set at the factory. However, it can be changed by a Caterpillar service technician. The operator can also disable regeneration or manually initiate regeneration from the cab. While in automatic mode, the engine ECM can initiate regeneration at low speed while the machine is at idle. This occurs anytime the soot level reaches 30% or more and various idle opportunities are met, such as parking brake on, transmission in neutral, and implement down. When the high-speed setting is enabled, regeneration is initiated while the machine works as soon as soot levels reach approximately 60 to 70%. The advantages of low-speed regen are that it takes less time and uses less fuel than high-speed regeneration. The maximum number of minutes required by the system for low-speed regeneration is 20 to 25 minutes to clean a full diesel particulate filter. High-speed regeneration times will vary. In light work applications, however, some machines may not need regeneration for several shifts. This simulation demonstrates how automatic regeneration takes place. In this first screen, we see that the parking brake is engaged and the message display indicates that the regen status is programmed to automatic. Next, the parking brake is released and the RPMs increase. On the display inset, we see that the machine is now operating in third gear forward while traveling at 5 kilometers per hour. The soot gauge and the soot load on the chart track in unison as the soot captured in the DPF rises from 0% to 15%. When the regeneration status is set to automatic, the engine ECM can command a low-speed regeneration when the DPF soot level reaches 30% or greater, when it determines that the machine is in a non-work condition. If suitable machine conditions are not met, regeneration will not occur, and the soot level will continue to rise. When the soot level reaches approximately 60 to 70%, if high speed is enabled, the engine ECM will initiate regen while the machine works. The machine continues to work, and the soot level rises to approximately 65%. The operator idles the machine, and we see the parking brake engaged. The machine is in neutral, and there is 0 ground speed. The ECM, sensing a non-work condition, commands regeneration. Below the display, we see the regen active lamp illuminate. With the machine stopped and in neutral, regeneration continues. The regen active lamp remains on. The soot gauge and the chart both reset from a 65% soot load to 0% after a complete regeneration. When the regeneration cycle is completed, the regen active lamp turns off. Keep in mind that regeneration raises the temperature of the clean emissions module near the engine. If you break for lunch and the ECM initiates regeneration, be careful when you return to work and do your walk-around inspection. When checking fluid levels, there are components in the engine compartment that may still be hot. Also, when regenerating while on break, someone must always stay within 25 feet of a running machine to meet U.S. OSHA worksite regulations. This simulation demonstrates how manual regeneration occurs. If the machine is set to manual regen, the soot continues to accumulate in the DPF. It's important that the operator monitor the soot gauge and indicator lights. At 15%, the operator has the opportunity to manually command a regeneration, if desired, using the manual regeneration switch in the cab. We will now discuss what happens when regen doesn't take place and the soot level increases to 90%. At 90%, the DPF lamp illuminates on the dash to inform the operator that it is time for regeneration at the next available opportunity. In this simulation, the regeneration status is set to manual, the parking brake is off, and the machine is once again working. In our last simulation, we saw regeneration take place at 65%. In manual mode, the DPF will continue to accumulate soot until the operator presses the manual regeneration switch in the cab. Here, we see that the DPF lamp has illuminated. Again, this tells the operator to regenerate at the next possible opportunity. The operator continues to work. The soot continues to increase in the diesel particulate filter, and before it reaches 100%, the operator determines that it is time to regenerate. The operator takes a break and places the machine into a non-work mode. The engine is at idle, the transmission is set to neutral, and the parking brake is engaged. The operator presses the manual regeneration button and holds it for at least 2 seconds. When the regeneration cycle begins, the regen active lamp illuminates. The soot level in the DPF eventually returns to 0% after a full regeneration has taken place. Regen can be interrupted at any time if the machine returns to work. Let's look at what happens when regeneration is disabled. The operator can disable regeneration using the manual disable switch, number 1, or disable button, number 2, in the cab. The regeneration status will appear as disabled in the display window. Why would we disable regeneration? We disable it if we're working in an application where there is flammable debris such as wood chips or dry forest conditions, or if there are gases, dust, or other risks that we need to avoid. So we disable regen, and when the machine is in a safe stationary setting, we manually initiate a regen cycle. Similar to manual mode, with regen disabled, the soot continues to accumulate in the diesel particulate filter until we initiate regeneration. As operators, we have to pay attention to our warning signs. Whenever the soot gauge reaches 100%, the red action lamp begins flashing continuously, telling the operator to regenerate immediately. There are several possible explanations for a DPF having a soot load of 100% or more. The most common reasons are that the operator didn't create a sufficient non-work window to allow low-speed regeneration to occur automatically, was working the machine too hard to permit high-speed regen to occur, or didn't initiate regeneration while in manual mode. Another possibility is that regeneration has been disabled by a service technician or operator. Our last simulation demonstrates what can happen when regen is disabled. When regeneration has been disabled by either a CAT service technician or by the operator using the disable switch in the cab, soot continues to accumulate in the DPF. Once again, we are in third speed forward, traveling at 5 kilometers per hour. Here, the DPF lamp has illuminated just like it did in our manual example. In disable mode, the various warning indicators continue to be prompted as they would if the regeneration status was set to automatic or manual. Look at our soot gauge. When the bar is completely filled to the far right, it's at 100% soot level. At 100%, the action lamp begins to flash continuously. The engine also begins a mild derate. The useful range of the DPF is from 0% to 100%. However, with the soot gauge at its maximum level, the soot level does go higher, and the warnings become more aggressive. When the soot level in the diesel particulate filter reaches 116%, the audible alarm sounds in the cab. The DPF lamp remains on, and the action lamp continues to flash. The engine derate progressively increases as the percentage of soot increases in the DPF. If you continue to operate the machine for another 5 minutes after reaching the 116% soot level, the engine ECM forces the engine to idle down. The warning lamps and audible alarm continue. The operator can turn the key off and restart the engine to clear the idle down limitation. At this advanced stage of soot accumulation in the diesel particulate filter, the operator should regenerate the DPF immediately. Should the operator continue to ignore the warnings and permit the soot level to reach 116% plus 10 minutes, a severe engine derate begins. The audible alarm and warning lamps continue. And most important, when this 116% soot level and 10 additional minutes of operation have been reached, the machine goes into a lockout mode. The operator is no longer able to initiate a manual regeneration or allow the engine ECM to initiate an automatic regeneration. Once the machine reaches lockout mode at 10 minutes of operation, after reaching 116% soot level, a service technician must be called to perform regeneration using the CAT Electronic Technician Service Tool. We're talking loss of production plus a service call, which is added cost and time. An operator should never let a machine get to this condition. But, as you will see shortly, it really can get worse. Total soot saturation of the diesel particulate filter occurs at 140%. At this stage, the diesel particulate filter can no longer be regenerated and must be replaced. Performance is also greatly curtailed, and it may take you extra effort just to move the machine to a suitable spot for servicing. At 140%, the engine ECM will first force the engine to operate at low idle, followed by immediately commanding the engine to shut down. The operator can restart the engine and run the machine for an additional 30 seconds at a time to reach a suitable area to safely park the machine. You can use this key-off, key-on restart method indefinitely, but you only get 30 seconds runtime with each restart, and the engine speed is limited to the low idle setting. Basically, the system lets you limp the machine to a safe state. After each 30-second runtime, the machine shuts down and must be restarted with the key. Delayed engine shutdown is a cool-down sequence that idles the engine for 5 minutes to protect components inside the engine compartment. This feature should only be disabled in emergencies when immediate engine shutdown is required. When enabled, the delayed shutdown sequence will occur automatically at key off, and an icon, shown here, will illuminate on the instrument panel. The 4-position key start switch was developed to provide an emergency stop feature that disables the delayed engine shutdown feature. It is intended for emergency use only. To initiate an emergency shutdown, the operator moves the key counterclockwise from the on position past the detent at the off position to the new emergency off position at the far left. This 4th position is spring-loaded, requiring the operator to hold the key in the emergency off position until the engine has fully shut down. Releasing the key returns it to the standard off position where it can be removed from the switch. On Tier 4 motor graders and articulated trucks, an electric fan with the delayed shutdown feature is used to reduce heat in the engine compartment instead of delayed engine shutdown. These machines continue to use a 3-position switch. When leaving a motor grader or articulated truck, the battery disconnect switch should not be turned off until the fan has run its cool-down cycle. Machines that offer the delayed engine shutdown feature may also offer key-off regeneration. To utilize the key-off regen function, the machine must be in either automatic or manual regen before the key switch is turned off. If the machine is in auto regen before the key is turned off, the engine will continue to run for 15 seconds. The operator must press the manual regen button within the 15-second window to enable the machine to perform a key-off regen cycle. After regen is complete, the delayed engine shutdown timer will begin counting down from 5 minutes to cool the engine compartment and protect the electronics. Be sure to check for any rules or regulations that apply to your work site regarding unattended machines. Someone may need to be assigned to monitor machines as they regenerate. To meet U.S. OSHA worksite regulations, for example, someone must always stay within 25 feet of a running machine. The information contained in this presentation is current as of August 2010. Operators should always check their operation and maintenance manual for detailed guidelines about Tier 4 features on their machines. For further and up-to-date information about Tier 4, refer to the CAT Operator Training website, www.cat.com/training.